Hello everyone, welcome back to Tech Wizards. And today we will learn about what is logistic regression and how it works. And using logistic regression, we will create a simple classifier. In my previous video, I talked about linear model, which takes x as an input and we perform some linear operation on it and we get y. In logistic regression, we take x as an input and we classify whether it belongs to class A or class B. So now let's see where do we use logistic regression. Logistic regression is mainly used when the outcome is a discrete value. So like if we want to see who will win the election, whether student will pass or fail in an examination, whether an email is spam or not spam, whether a customer will come back or not. So in all these scenarios, we can make use of logistic regression. Now let's see how it actually works. So now let's try to make a simple model using x1, x2 and x3, where x1 variable represents the age of a candidate, x2 represents their corresponding blood pressure, and x3 represents the person is a male or a female. And we want our model to predict the death of that person given x. So first of all, let us create a very simple model, and this represents the simplest model that we can create, like W0 plus W1 into x1 plus W2 into x2 plus W3 into x3, which is equal to W transpose into x, where x represents 1, 2 and 3. So when age is large and W1 is positive, we can see that it is more probable that the person is going to die. Similarly with blood pressure, higher the blood pressure means higher chances of death. But we can see that there is one problem here. Problem is that we are not getting any probability here. So to solve this problem, we make use of sigmoid or S curve. This here represents the sigmoid curve, and this here is the equation 1 upon 1 plus e to the power minus t. Using this, we can get probability, and then we can use some threshold value like 0.5. If the probability that we have calculated will be greater than this threshold value, then we can say that it lies in class 1, otherwise it lies in class 0. So mathematically we can represent it like this. We just need to place this value in place of this t here, and it will be able to give us the probability between 0 and 1. So now let's have a look at the loss function that we will use with logistic regression. In my previous video about linear regression, I used mean square error as my loss function. But we cannot use that same loss function here, as it do not perform well with logistic regression. So we use cross entropy as our loss function. It measures the performance of a classification model whose output is a probability value between 0 and 1. Cross entropy loss increases as the predicted probability diverges from the actual label. And this represents the formula for the cross entropy loss function. And now let's see how we will reduce this loss function. We will reduce this loss function using the stochastic gradient descent. The major difference between the gradient descent and the stochastic gradient descent is that in gradient descent we compute the cost gradient based on the complete training set. Hence we also call it the batch gradient descent. If we have very large data set, using gradient descent can be quite costly, since we are only taking a single step for one pass over all the training set. Thus, the larger the training set, slower our algorithm updates the weight and longer it may take until it converges to the global cost minimum. Whereas in stochastic gradient descent, we update our weights for every data point. Now let's create a simple classifier using logistic regression, which will classify whether a student will pass the exam or not based on the number of hours he studies. So first of all, we import all our necessary dependencies like torch, variable, neural networks and matplotlib. And we have defined two variables, that is x data and y data. X data contains the number of hours a student studies, and y represents the probability, that is 0 or 1. First of all, we plot all these points on a graph using the matplotlib. Then we have defined a class naming model, which inherits the neural network. And inside the constructor, we have defined the linear method. It shows that it takes one as an input, one variable as an input, and one as an output. And we have also defined a forward function which helps our network in moving forward. And at the end, it's going to return the predicted value. And we have created the object for our class. We have also defined the binary cross entropy loss and the stochastic gradient descent. And we are going to train our model for 1000 iterations. And for each iteration, it's going to pass the variable to our model, and our model will return the predicted value. And we pass both the predicted value and the original data to our cross entropy loss function. And then we optimize using the stochastic gradient descent. Now, after training, if we want to check how our model is performing, what we have done is we have defined two variables, like our variable, and we have passed it to our model. And if the probability is greater than 0.5, then it will return true, else it will return false. Now let's try to run this up. And yes, one more thing. The only difference here from the linear regression model in which I talked about in my previous video is that here I am using the only self.linear.x, whereas in logistic regression, what I am doing is I am passing that to a sigmoid function. This is the only difference. So now let's try to run this up. Let me just open up my terminal. So as you can see, these are the data points. And after training for 1000 iterations, our loss function is reducing. As you can see, it was earlier 0.44, then it kept on reducing. And at the end, we have got our value. That is, for 1.0, it is false, and for 7.0 is true. That if the student is going to study for 7 hours, then he is gonna pass. Otherwise, he is gonna fail. So yeah, that's it for today, guys. And if you like my channel, don't forget to like, subscribe, and share.